Hello, hello, and perhaps inspired by last week's Zelda-themed puzzle by Viking Prime, I got a suggestion for Nurator's Sudoku-like, or I guess it's a roguelike puzzle, which I'm excited to try out. It's only rated 2 stars on Logic Masters Germany, so hopefully this won't be too difficult. I have no idea what's going to happen in this puzzle. I don't even know if I mean, I guess I'll explain the rules to this level one puzzle, but there are three or four levels to this puzzle, and I have no idea what's going to happen when I get to level two. So, yeah, I'll just try it. Yeah, and if you notice, if you have a video game themed puzzle, I'm probably going to I'll probably try to do it here, because that piques my interest. Anyway, so in this puzzle, we have normal Sudoku rules, we have killer cages, and so in a killer cage, digits can't repeat in the cage, and they have to sum to the given total. In this case, is 6. And then if we have a class, which is the region sum warrior, which just means these lines are region sum lines. And what a region sum means is that in every box it enters, it has to have the same sum in that box. So this digit will have the same sum as this digit, meaning they'll be the same digit. And whatever digit that is will sum to these two, will have the same sum as those two. And if I solve this puzzle, I'm allowed to enter level 2 and take my class with me. Hopefully that will make more sense what that means when I see the rules to level 2. But it says if I descend deeper, I'll unlock more classes. So I think for now, I'm just going to solve this just like a normal puzzle with these gray lines being region sum lines. So let's try it. So 6 cage and 3 has to be a 1, 2, 3. With this 13 cage. So this is a 3 by 2 Sudoku, so I'm going to have the digits 1 to 6 in each little rectangle, row, and column. Here, the digits 1 to 6 should add up to 21. So this being 13 means those will sum to 8. So these are going to sum to 8, but I don't have 1, 7 as a choice. So because I don't have 7 as an option. So 1 won't be in here, and 4 won't be in here. So and 4 sees this whole cage. So 4 is going to go here. 1's going to go in here somewhere. I'm trying to think if that interacts with this. So this digit in particular, where is it going to go in what I'm going to call box 2 over here? It can't go over here because it's in the same cage. It's not a 4. It can't go here where the column. So it's going to be in one of these two. Um, I really want to say it can't be here, but it could, right? These could all be 3s. 3, 3, 3, 1, 2, 1, 2, I think works. I think that works. Um, yeah, I think that works. So this isn't a 1 because that is on a region sum line with all these digits. So this is at least 3 and it's not a 4. So and these are the same. I'm gonna color that this nice purple color. Or to mean these are the same digits because they're on a region sum line. And the only digit in its box. Uh, and these are either 2, 6 or 3, 5, which means one of these is a 1. Yeah, 1's not in here. So 1 is in this box, meaning it's not here. Uh, so if these are 3, that's 1, 2. That's also a 3. So I get 3, 3, 3. 3. Oh, and that breaks because 3 can't be on this. If the purple is 3, 3 can't go on the region sum line down here because it'd have to add with something else to also get 3. But if these are 3, that's a 1, 2 pair. This is a 1, 2 pair. Where does the 3 go in box 6? Nowhere. So these aren't 3. Which means this digit is going to go here. I'll label that blue. And then that digit is going to go on here as well. So it's definitely on the region sum line. So if this is 5, that's a 2, 3 pair. If it's 6, well, that doesn't work, right? Well, hold on. Well, how does this work? If this is 5, this just can't be 1, 4 because the 4 is there. So it's a 2, 3 pair. That works okay. If it's a 6, yeah, same thing. Without a 4, this has to be a 1-5 pair. But where then does this light blue color go in here? Nowhere. So this purple is 5. And I'll get rid of that coloring. This is a 2-3 pair. I don't know if that coloring is going to be helpful. This is 6. These sum to 5 and can't be 2-3. So this is a 1-4 pair. It can't be 2-3 because then what would I put in the light blue box? I need 5 here somewhere. This is now a 1-2-3 pair. 2-3 sees this. That's a 1. This is a 5-6 pair. This is the other of 2-3. I'm going to not color it. I'm guessing I'll be able to finish this fairly quickly. Yeah, without this 5, that means this is a 2-6. That makes this 3-2. Whoops. And I need a 6 in here. Can I do something with this 8 cage yet? What's in here? I know for sure I have a 5. So this has to be a 1-2-5. Making this a 4. This becomes now 4-6. This is 1 and 3. This can't be a 3-4 pair because that sees this is a 1-6, making this 2. And these then are 3 and 4, but I know how that goes. And the 3 in the corner. This is now a 2-3 pair, which tells me up here what's going on. What's in here? There's no way this is 1, right? Because if this is 1, this has to be 5-6. So that's 6-1. What is this? It's either 1, it's got to be 1-5. That makes this 6. 1, we have to go 6 here. So this is 5-2. 2-3, I know which way that goes. I know which way this goes. I know which way this goes. And I know this is 4 or 5. That's right. It doesn't have a solution. So I think that's right. Which I think means I get to go to level 2. So what is level 2? Here, I'll start this so you can see something. So congratulations for getting to level 2. Normal Sudoku rules apply. Little killer clues on the outside. So that's these numbers with the diagonals. They show the sum of digits on the diagonal. So for example, these 3 digits will sum to 8. These 3 will sum to 7, etc. Digits on the green line, that's here, differ by 5. That's a normal German whisper line. Digits next to white dots, that's these, are adjacent, so they're normal white kropki dots. You still have the same class that you finished level 1 with. Meaning, so the level 1 class was warrior, I think, the region sum warrior, meaning these could be region sum lines. This affects all gray lines in this puzzle. If you solve this puzzle, you're allowed to enter level 3 of the dungeon and take your class with you. Okay. You also unlock the epic Renban sorcerer. Lines contain a set of unique consecutive digits. So here that'd be very powerful because this would have to be essentially a new region of the digits 1 to 6. If I want to switch to this new class, restart the dungeon from level 1. So I'd be able to go back to this puzzle and redo this as if it were a Renban instead of a region sum line. And it would still solve. But why would I want to? Well, let's keep thinking. Okay, do I want to switch classes? No, let's just keep going. Let's keep going. Let's keep going with the region sum line. And if there's a reason, if there's a reason to restart, I'm sure it will become apparent in future rules. But let's just try this with the region sum. So how's this going to work? These sums are kind of drawing my attention because like this 7, this can only be as high as 4. I guess these can be as high as 5. But I know that this sum, therefore, the sum on this line is no more than 6. And if it's 6, that makes this a 1. That makes this a 2-4. Well, it'll be 1, 2, 4. This would be 1, 5. This would be 1, 5. 1, 5. That's okay. Hold on, no. No, because this sum is also on this 8. So if this were a 6, this would have to be 2. This would have to be 1, 2. That doesn't work. So this can't be a sum of 6, right? Because this is a sum of 6. This is 1, this is 2. But if this is 1 on a white kropki dot, that would also have to be 2. So how low does the sum have to be? Probably can be 5. If it's 5, this is 3, and this is 2, and this is 1. So this would be a 2-3 pair. This would be a 1-4 pair. That works. This would be a 2-3 pair. Yeah, that works. That seems to work. Can it be 4? No, it can't be 4 because then these are all just 1 and 3, which breaks this. So this actually is. So that is this says sum to 5. But the line in each box sums to 5. So that makes, what do we say? That makes this 3, this 2. With the kropki out to work, that's a 1. This is sum to 5. Now that's a 2-3 pair. This has to be a 1-4 pair. Because of this 1-4, that's a 2-3 pair. This is a 4. These are 5, 6 in some order. Oh, this is, I could have done this right away. That's a 1-6 pair because I only have the digits 1 to 6. And so for the German whisper to work, that's the way it has to go. And this is whatever's left over. 1-4 looks at this, so I know it's 6-1, 5-1. This is a 5-6 pair, so this is a 4. That's 5 and 6. Can I do something similar? Whoops. Can I do something similar here? Like, what is this one? This one probably has to be pretty high. I mean, it's at least 8, right? Because these digits, like this digit is 14 minus whatever the sum is. This is 13 minus whatever the sum is. Oh, there's a 5 in here. Uh, 4 is in here. Well, let's do the same thing. So what? But this could just be so high. It could be as high as 11. No, so it can't be one that would have a unique sum. For the same reason this couldn't be 4. This can't be 11 because it'd be 5, 6, 5, 6 everywhere. It can't be 10. That's 6, 4, 6, 4 because we don't have digits higher than 6. If it's 9, we can have 6, 3, 4, 5, which works. And then if we have 9, these become 4, 5. So these are from 4, 5, and 6. And it definitely has a 5 in it. So it can't be 6, 5 for the same. So yeah, this is very symmetric. This couldn't be 1, 2 because wherever the 1 went would have to have a 2 on the kropki dot. This can't be 6, 5 because wherever the 6 goes would have a 5 on the kropki dot. So neither of these can be 6, which means that's a 5, 4 pair. The 5 is going to go in the higher sum. 6 along there, that's a 3. And the sum is therefore 9. And this is going to be the 4, 5 because of the 6. And this 4, 5 on the other box means I know which way it goes. This is a 3, 6, so I know which way that goes, which tells me the 5, 6. And another 1, 4. And this is 1, 2. Yeah, this is just going to finish now. This is 2 and 3, 1. Okay. I think that's right. Okay, level 3. Let's get going. I'm sorry. I'll read the rules in here so you can see the puzzle. Congratulations for getting level 3. Normal Sudoku rules apply. Little killer clues on the outside. It's the same as before. Sum the digits on the diagonal. Sum to that number. I still have the same class that I finished level 2 with, and you cannot change this class. This affects all lines in the puzzle. If you solve this puzzle, you're allowed to enter the epilogue and take your class with you. You also unlock the legendary Modulo rogue. Every set of 3 sequential digits along a line must contain a complete set of residues modulo 3, i.e. 1 digit from 1, 4, 1 from 2, 5, and 1 from 3, 6. If you want to switch to this new class, restart the dungeon from level 1. There's another thing. It is intended that not all classes can finish the dungeon, okay? If you can trivially prove, I don't know what trivially means, but we'll take that. We'll see what that means. If you can trivially prove that your class cannot solve this puzzle, restart level 1 with one of the other unlocked classes. I see. So we have 3 classes so far, and there might be another class in the last one. And presumably only one, I mean, maybe more than one, but not all, according to the rules, will be able to solve it. So we need to look for reasons that, like right now we are the, what was it called? The something warrior class. Um, the something more the the region some warrior class, I think it's called. Um, yeah, the region some warrior class. And okay, but that can't work here. I mean, I can see right now. I guess that's what he means by trivially, or he or she means by trivially, is that um, that I can see right away just looking at this line that region sums aren't going to work because what this is at least 10 and this only goes up to 6. So we have to restart. I'm trying to think 1, 2, 3, 4, 5, 6. I was trying to see if there's a reason Renban couldn't work. Because if I can trivially show that Renban doesn't work, or the modular line, I don't have no idea how I would show the modular line doesn't work. If I can show that Renban doesn't work, I can skip it. So if this were Renban, this would go here. Hmm, I think the word trivially means I shouldn't think about it too hard. What about actually? So now I'm thinking the mod because the way the module line is going to work is this digit would be the same modulus class as this. That cause any problem? Like, and these would be two separate groupings of those. These would also be two separate groupings of those. It's just not. I certainly don't think it's trivial. These would be the same. Hmm. Yeah, I don't think it's trivial to show that either one doesn't work. So I think I'm gonna have to. I think I'm gonna have to restart. So which class do I choose? Um, let's just go in order. So we'll go back to level 1 and we'll take the Renban class. And we'll try to do this as if these are Renbans. So let's try that. So, okay, what logic can we preserve from before? I think we put a 4 in here without using the region sum line, right? Because this has to sum to 8 still. 4 can't go in here. So that's a 4. Because 4 can't be in 2 digits that sum to 8 without a second 4. This is 1, 2, 3. 1 has to be up here still. Yeah, I think from there I went to region sum logic. So let's think about Renban logic. This 4 has to be this Renban is 1 to 6. So 4 has to be on here, but it can't be here by row, can't be here by box, and here by column. So oops, 4 is in here somewhere. Now what? 4 could be in here, which case this is 1 or 3. So it's, ooh, 1, 2, 3, 4. These would be 5, 6. That seems fine. This digit, I was thinking, where does this go in this box? But it could go here. Let's look here. Actually, this is more interesting, I think, as a Renban than it was as a region sum line, because all three of these digits see this 5 cage. So it can't be 1, 2, 3, for example. Because if it's 1, 2, 3, that means neither 1 nor 2 nor 3 show up in the 5 cage. In fact, does that mean it has to be 4, 5, 6? I'm trying to think through the possibilities. So if it's 2, 3, 4, you can't have 2, 3, or 4. That will break it. Even if it's 3, 4, 5, that will have 3, no 4. That'll break it. So yeah, so this is 4, 5, 6, and the 4 won't be up here, meaning I get a 4 here. 4, 4, 4. So the 4 here means that's a 2, 3 pair. This is from 1, 2, or 3 across the 7 cage from this. Oh no, I was about to say something not true. This needs a 1, and so that's not a 1. And it's 1, 5, or 6, and this therefore can't be a 4 because 4 had to go with 3. So this is 4, this is 4. This is 1, 2, 5. 1, 2, 6, sorry. 1, 2, 6. That means 3 has to be up here. This 4 in the 8 cage means, so my 4 is in here now, not in the 8 cage. This is a 1, 2, 5, meaning these are 3, 4, 6. I get, what do I get? I don't know what I get. This 2, 3 looks up here, so this could be a 1 though. I need 1, 5, and 6 in these in some order. I'm gonna mark every digit in this puzzle, aren't I? Before I did something like 1 had to be in here, so it couldn't be here, but I think that was because it's a region sum line, so this couldn't be 1. But this can be 1 for our Renban. I'm trying to go through some possibilities and see if that breaks something. Like if this is 3, 4, if this is 2, 5, that has to be 4. 2, 5, 4, 6. I don't, oh, 2, 5, 2, 5, 6, 1, 6. No, that looks good. Um, this can't be this can't be a 2, 3 pair. That's interesting. This can't be a 2, 3 pair because I need 8 here, and one of them has to have a 2 or a 3 in it. So this needs a 1. So this still isn't a 1, but for a very different reason. I mean, I guess that logic existed before, but much easier logic with the region sum line prevented me from seeing that. Oh, this is a 1, 2, 3, 5 quadruple. That's a 6. That's easier. So neither of these are 6. One of these is a 6. Do I get any cool? So that's not a 6 because that sees both of these. These aren't 6, which means 1. So if this is 6, the 6 is going to go here. So one of these is a 6, which means this is a 6 because in this box now, 6 has to go here, which means 6 can't go here. 6 is here. This can't be 2 anymore. This can't be 6 anymore, so this can't be 1. Oh, I guess I knew that. I've always known that. 6 can't be here. So this is 2 or 3. So these are 1, 2, 3, 5. So this can't be 3. So 3 is down here somewhere. So that's not 3. That is 3. These are now from 1, 2, 5. Where does this go in this box? It's got to be the 2. Yeah, 3 is in here. So that's 2. The 2 could go up here and on the Renban. Okay, so I need a 3 in here. So this is 1, 3. This is now 3, 5. That's my 1. 2, 5. 2, 5. That's the 2. That's the 5. Therefore, this is still a 1, 5 pair. This is a 2, 6 pair. I know from this 4, 6 how that goes. Making this 2, 5. 2 on the right box tells me how that goes. 1, 5, I know. 3, 4, 3, 6, 4. 5. Oh, over here. Okay. Yeah, so now now I take that to level 2 after this again as a Renban. Okay, so now, okay. As I was saying before, this is really powerful, the Renban, because this is like a new region. It's the digits 1 to 6. This, just as before, is a 1, 6 pair. And this, I'm going to color code these. Let's call this green. Where's green on this Renban? It's not here. It's not anywhere here. So green is here. Do the exact same thing with these. I can do these, and this is a different color than those. So I'm going to make this a new color, and this also is a different color. So I did this cool pattern. And what does that tell me? I'm not sure. I'm not sure what to do with that, but there's a lot going on here. Let's go back to the 7 and 8, like these little killers. So these are all fairly small, but I don't get anything like that pattern we had where these had to be one apart because these are one apart. Because I mean, these are by definition going to be different digits at least. They could be the same sum, but they don't have to be. Um, hmm. So these are from 1-6. Uh, oh, green is in here, and orange is in here. And I think one's not going to be allowed to be in here, and six is. So what if this were six? These would both have to be one. That doesn't work to make eight. Here it's even worse. So green is one, and orange is six. I'm gonna get rid of that coloring now. Let's say one is in here and six is in here. One of these is a two, whichever is across from the one. Wherever the one is, the two will go across the kropki dot from it. Which means the other one's not two. Actually, that's kind of interesting. So the lowest the other one could be is three. And does three work on this eight? This is 3, 2, 3. Oh, it just works. 3, 2, 3. Well, if this is 3, 2, 3, that's a 1. That makes it a 5. 1, 2, 3, 5. This would be 4. Yeah, that just works. Or the other way. If this is a 1, this is a sum to 7. That's pretty easy. Okay, how about over here? I need a 5 on one of these. No, these are going to be exactly symmetric. Okay, if it doesn't work over here, I don't think it's going to work over here. Well, okay, but these aren't two because two has to be in one of these. Either way, it sees both colors. So these are actually from 3, 4, 5. And they don't see 5 for the exact same reason because 5 has to be in one of these. So these are a 3, 4 pair, which means these are a 2, 5 pair each way. So the other digit is at least 4, which doesn't work without a 1 here. If 4, 3, 2 is 9. That doesn't work on the 8. So the 8 gets the 1, interestingly. And then this is at least 4. 6 doesn't work with the 7. So that's 4. That's 2. Purple has to go in here. So purple is, I guess they're both purple. The lighter purple is 4. The darker purple is 3. I don't need that coloring anymore. I need a 3 on the Renban. I could go anywhere. This is 3, 5, 6. That doesn't really help me. Okay, hold on. I feel like I should. Okay, let's do the. Okay, yeah, this is the 3 by the little killer 8. This is a 4 by the little killer 13. These summed 8. So this could be. Oh, it can't be 4, 4 because of this 4. So it's 3, 5. And now this is a 1, 4 pair. This is also 1, 4 pair, but I know how that goes. So it's 1, 4, 1, 2. This is a 2, 2, 1 pair, and I know how that goes. This is a 4, 5 pair, and I know how that goes. This is 5, 6. This is 2, 3. This is 5, 6, 6, 3. I'm gonna have to go back and watch each of these and make sure I did them correctly, but because there's no solution check. Of course, there's no solution check because there's multiple. I'm sure the digits are different. I mean, yeah, the digits are clearly different here than before. Okay, let's move on to level 3. So now I have to do this with renbans. So all these gray lines are now renbans. One of these is a 1, 2, 3, and one of these is a 4, 5, 6. But none of the little killers look in there, so that's not helpful. This is a region of 6. This digit, I think I said this before, goes in here because it can't be on the Renban with itself, and it can't go there by Sudoku. So this is here, which means it's up here. I don't know if that's where does green go on this Renban? I guess there are 3 places it could go. These ought to be fairly small to be 10. What's the largest a digit can be? Because this is 1, 1, 1. Oh yeah, not that small actually. Yeah, we're in 1 to 6 world, so the digits are kind of small anyway. So does that mean these are pretty big? How small can these digits get? 6, 6, 1. I can still have a 1 on here. Not here. This can't be a 1, but these could be. Oh, yeah, this could be a 1. This can't be 1 either because I have 6, 6 on the Renban. But this could be a 1. Oh, no, it couldn't because I would need 6 there. So there's no 1 here. Not worth marking? I don't think it is. Could this be 2? That's 2. The highest it could be is 5. That's 7. That's 6. That works. 2, 5, 6 works. Yeah. This is the digit that's not on this Renban, which means it's 1 or 6, because this is going to be a set of 5 digits. This is none of those 5. If it's in the middle, it's going to break up those digits. So this is 1 or 6. Can it be 6? What would that mean? If this is 6, we'd have 1, 1, 2. Oh, that works just barely. What implications would that have? These would be from 3, 4, 5. That would be a 6 as well. That breaks. So if this is 6, these are 1s and 2s. Since there's a 1 in this Renban, this becomes a 1, 2, 3, 4, 5 Renban. Another way, let's do it in intermediate steps. This digit is not on this Renban because it sees this green cell, which has to be this cell. So by the same logic as this has to be 1, 6, this also has to be 1, 6. So now it's easier to see why if this is 6, to make the 10 work, this has to be 1, 1, 2. Then I have a 1 here and a 6 here, which breaks this cell. So this has to be 1, oops, this has to be 1, and this has to be 6. 6 is not on this Renban, so this is 1 to 5. I guess I knew that. Oh no, I didn't know that. So these are digits 1 to 5. I guess, no, I did. I kind of knew that from these are the digits 1 to 5, and this is this. The greens are the same. 6 is in here. That's not. Okay. This is either 1, 2, 3, or 4, 5, 6. Oh, but I almost said this had to be 6, but it's not sure. I could put a 6 here. Sorry, I was thinking 1 or 6 had to go here. Well, actually, no, 1 or 6 does have to go here because 1 and 6 are not on those. One of them can go here, and the other one has to go here in the column. So what I said was true, but for a completely different reason than I was thinking in my head. And I can't put 1 and 6 both on this Renban because I only have one cell to connect them. So the other one has to go here. It can't be 1. So that's 6. 1 is in here with 2 and 3. 4 and 5 are in here somewhere. So this is not 4 or 5. This is 2 or 3. Oh no, I don't get it. So the most this could be is 9, these two together. So this has to be at least 4. And 6 goes on this Renban here somewhere by Sudoku logic. So this is 3, 4, 5, 6 on this Renban. If this were 3, these would add to 10, so it'd have to be 4, 6, or 5, 5. Well, what's the smallest this could be? Oh, it could still be 1. No, it could be 2. 5, 6, 2. Yeah, and this could be 7 fairly easily. Okay. This can't be 1, 2, 3, or 2, 3, 4. So it's at least 3, 4, 5. It definitely has a 4 and a 5 on it. If it has a 6 on it, it's here. These are 4, 5, 6 as well. Oh, hold on. This can't. Oh, it can be. I was thinking because I had two, but the doubles are in different columns. Where does 1 go in this column? It's got to be here. Where does 1 go in this box or column? It has to go here. 1 therefore is here. And 1 is here. 1 can't be on this Renban with 4 and 5. This can't be 1, 2, 3. So 1 is here. This is the 1. We need, how do I make this 11? This has to be at least 8, even if this is 3. So this is at least 2 is all. 6, 2 works. Okay. This is not a 2 because this is 3, 4, 5, 6. So 2 in the column goes here. This is now a 1, 3 pair. Therefore, this and this, which is not in the run band, has to be here to be in the column. So that's a 3 there. These are 2, 4, 5 in some order. 2 in the box has to go in here, so it's not here. 3 has to go in here, so it's not here. 3 is one of these. This is 2, 3 pair. This is 13 now. That's 9, so that's 4. 6 has to go here, where corner mark. 3 has to go here, that's a 5. This is 4. This is now 4. 4 is not here anymore. 3 is not on here, so this is now 4, 5, 6. 6 has to go here. This is a 1, 2 pair. 2 has to go in this Renban, so it goes here. 4 and 5 have to go in the Renban, so there are these. I know the order. I get 2 has to go here, 4 has to go here, 5, 6, 3, 2. 6, 5. 5, 2. Okay. So we keep going. Oh, it's a new level. We get to, sorry. You finished the dungeon. Congratulations. The only thing left to do is to get the loot. Hopefully your class is able to unlock the chest. Enter the digits 1 to 4 in each row, column. Okay, so this is now a 2 by 2. So it's a 4-digit Sudoku box. Little killer clues on the outside. That's these 8s. These sum to 8. On the outside show the sum of all digits on the marked diagonal. You still have the same class that you finished level 3 with, and you cannot change this class. This affects all lines in this puzzle. It is intended that not all classes can, so this is the same as before. You can trivially prove that your class cannot solve this puzzle. Restart level 1 with one of the other unlocked classes. If you solve this puzzle, you actually finish the dungeon. Okay. So we are Renbans. And Renbans don't work here because I can't put a 5. Yeah, so when Nurator said trivially, they really meant trivially. Yeah, can't put a 5. So I have to restart with modulo lines. Because there's no, is there a new class here? I didn't see a new class. Yeah, I don't see a new class. So now we will really have exhausted this puzzle because we did them in order, which is probably for the best. Although it does mean I'm probably going to take an extra 20 minutes solving these with another line. But it's wild that this puzzle solves with all 3 line types. I mean, that is it's just something you look at and you're kind of in awe because how do you set something like that? But anyway, now we're summing this with modulo lines. How do I want to do this? I don't even know how to. Okay, same logic. 4 goes here, and 1 goes up here. I did something before that said 1 had to be up here, but I can't remember what the logic was. Why can't 1 go here? If 1 goes here, it had nothing to do with this line. If 1 goes here, oh, I get a 2-3 pair, which conflicts with this. So there's definitely a 1 here. 1's not here on the line. I almost said something wrong. But 4 is not here. And on this, oh no, that's wrong. I was thinking wherever 4 goes, 1 had to go 3 away, but that's not true because I could put in 4 over. Sorry, 1 would have to go here. So I thought that would mean 4 would have to go here. But I can put another 1 here. I don't need to put 1 and 4 both on this line. I can use the same digit to satisfy the modulo constraint. Okay, these are all different, and they can't be such that I take away all my 5 possibilities. So if 2 is on here, 3 is not. So if 2 is here, 6 is here. If 1 is here, 6 is here. Is there any way 6 is not on this? I don't think so. So I need, hold on. I need 1 from 1 or 4. Oh, I need 1 from 1 or 4. So this is a 2-3 pair. That's the way to think about it. I need 1 from 1 or 4. And 4 can't go here, but that doesn't mean 4 is here. I could put a 1 here or a 1 here. But I get the 2-3 pair. So these are from 1, 5, 6. And in fact, oh, these are from 1, 4, 5, 6, which is not quite as helpful. But 5 and 6 are definitely on this line, which means 5 or 6 can't go here. So these are fairly low, and this is fairly high. So by the 7 cage logic, it's 3, 4, 5, 6, but it's not 3 by the 5 cage here, so it's not 4 here. This is still a 1, 2, 3. I need a 1 in here, so 1 does go in here. If this is 1, then this is 1, and this is 1, and this is 1. How far can I go? 1, 6. I don't know which of these is 1. I think that's where the chain would end. Yeah, I think that's where the chain would end. If this is 1, I can still put a 1 here. Or a 4 here. I can do 4, 1. Yeah, that's too complicated. What do I do now? I need a 5 and a 6 in here somewhere. Can they go here? No, they can't both go here, because if they both go here, they go down here, but that doesn't sum to 8. So 1 of 5 or 6 is here. Which means this is not the 1, 4. Which means this is not a 1. So my 1 is, oh, my 1 is here. Gives me my 1 in the 6 cage. I get a 2, 3 pair. So the 2, 3 that goes in, the 2 or 3 that goes in my 8 cage goes here. Which means, yeah, that's just paired with this. This is either 5, 2 or 6, 3. How does that work with this? So if this is 6, this is 3, 5, and that's 2. So if this is 6, that's 2. And presumably that's 5, that's 2, 6, that's 3. So these sum to 8. These don't sum to 8. So this one is the same as this one, which means it has to go up here. So this is also 5, 6. Green is going to go down here. So these 2 digits, yeah, are going to go down here, which I guess I already knew kind of. Now what? If this is 1, that's a 4. And then these become the other of, oh, not quite the other of. Um, Hold on. Let's go to 7. This is 1, 4, 5, or 6. So this is 1, 2, 3, or 6. No. Okay. So let's go back to this modular logic. If this is 1, this has to be 1 or 4, but it can't be 1. So it's 4. So these become the different 2, 3, and 5, 6 pairs. So this becomes the 5, 6 that goes with this. This digit would go, oh, I don't know where that should go. I was thinking that would mean this would have to go. Wait. No, sorry, this goes with this. If this was 1, this would be the other, which is not 2 or 3. So this would also be 5 or 6. And then this would be the other modularity type, but it could be that 5, 6 again. Yeah, that could be this. In fact, that seems quite likely. Can I color 5s and 6? Let's color these, the 2, 3 pairs. 2, 3 is one of these. Is that the end of the line? I think that might be the end of the line. I don't think I get anything. Oh, no, I get down here. So orange is one of these. Can orange be here? If orange is here, I was going to say it doesn't show up on the line, but it can show up here. And it doesn't have to show up on the line, but I think it makes it hard if it doesn't. These and these have the same modularity. And it's not, hold on. This is the same modularity as green. I'm going to color this green. I'm going to color these by modularity, actually. I think is the way I'm going to do it. So this can't be the orange modularity because it sees both of the orange digits. This can't be the green modularity because it's too close to this one. So this is 1 or 4. That means it's a 4. That's not a 1. That's not a 4. So that's a 1. My 1 is definitely here. So that's not a 1. That's not a 6. These are orange digits, which I will just color orange. That's a 1. This orange digit these are the same orange digit because this has to go in this box somewhere. But which one is it? I don't know. And the other orange digit goes in here and in here. 4 goes in here, which means it's not in here. So this is a 1, 2, 5. There we go. 5, 2, 2, 3, 6. These are the same digit, 3 or 6. I'm thinking of getting rid of coloring so that those orange now mean they're the same digit. I need 5 in here. That's not helpful. With the other of 3 or 6. 5 then will go in here, of course. 1, this is 3, 4, or 6. This isn't 3. That's not 1, so that's not 6, so that's 6. That's 3. That's now 4. Now I wish I'd saved my modular coloring maybe, but we'll see. 4 is in here somewhere. This is a 5, 6. 1, 2, 3. This is 4, 5, 6. 1 is in here somewhere. Why did this? Oh, so this can't be 1. That's a 1. So 4 has to go in here because 1 can't. No, 1 has to go in here. Sorry, 1 has to go in here, not 4. 4, 5. I'm going kind of fast. I'm kind of worried I'm making a mistake, but I think this is all pretty straightforward. And I don't know if it's right because, and that was puzzle 1. I still have to do 2, 3, and 4. Okay, so I have to redo this again with modular lines. Okay. I'm going to color modularity. We're going to call this green. We're going to call this orange. We're going to call this blue. These are different modularity. This could be 1, 2. Ah, but these are different modularity. And I can't put, oh, I can put 6 on the, I can't put 6 here, but I could put a 6 here. 6, 1, 1 is okay. This is a 1, 6. So 1, 2, 3, 4, 5. This is the other. So if this is 3, that's 6, which with 2 1s would be okay. If it's 4, that's 1. If it's 3, no, if it's 3, it's 6. Why did I start there? If it's 2 or 5, it's the other. This is at most 4. Weak sauce that. Because this is almost 5. I mean, none of those are 6, I guess. I don't know. There's no reason. These are by the modularity. These have to be the same modularity. These are orange. Wait, did I that wrong? No, those are orange. Yeah, so this can't be 2, 5. This is 3 or 4. So these are also both orange. So this is 1 or 4. And it can be 4, because if it's 4, this would also be 4. And that would be 8 already, even without the Greek. So that's 1. That's 4. To make that 8, that's a 3. Hold on, 1, sorry. These are a 2, 5 pair. That is a 1. This is a 4. To make this 7, that's a 2. I need a 6 up here. This is a 2, 3 pair. This is a 5, 6 pair. This is 3 or 5. I can probably do the exact same thing here. I want to preserve that coloring because that's really useful, I think. Can this be 2? No, this would be 6, 6. So that can't be 2. Can it be 4? No, because it can't be 5, 5, and it can't be 3, 7. So that's a 6. This, therefore, is a 3. That's 9. This is a 5. Oh, what did I do? Let's try this again. If this is a 4. Oh, it's 13. I did all that wrong. Hold on, let's go back all the way. Sorry, I was thinking this was, I just misread the clue. This is, this sums to 13. So if this is 2, this needs to be 11, which it can't do because the 6 is gone. So it still can't be 2. If it's 4, this sums to 9, which would be 5, 4. That's okay. So 4, 5, 4 is one possibility. If this is 6, these sum to 7. 5, 2 could theoretically work, except that the modular line would break. 3, 4 works. Either way, that's 4. So this is a 1, 2 pair. 2, 3. That's a 1. We'll color these orange. Where does, oh, 6, hold on. Does 6 have to go on this line? Is that just a unique quirk of these being the same modularity, and might that not continue? So these are the same. These are the same. Yeah, I think this ends up being a Renban. Hold on. If this is a Renban, does that mean it's the exact same and I could have just left everything in? I really hope that's not true, but I think it's true. Hold on, let me go back and see if I can restore that. Oops. 3, 6, 5, 2. Yeah, this is already. I didn't have to do this puzzle again. That is so brilliant. I don't know if you meant this, but that is brilliant. And I can actually prove, I don't, so you might look at this and say, well, it's already a modular line. So therefore, it's a solution, which would invoke the uniqueness of the presumed uniqueness of the puzzle. But you don't actually have to do that, right? You can say, look, assume this is a modular line, right? Assume this is a modular line, then what happens? Ignore the numbers here. These two are the same modularity. These two are the same modularity. These two are the same modularity, right? So I need to have 6 separate digits because within the same modularity, they see each other and so they don't repeat. And so what you can say is if it is a modular line, then it is a renban. And because it's a renban, I've already done all this logic for renbans, which would also apply to the modular line. And I'm just going to use that. And I think that is perfectly valid and awesome. And that's just incredible. Well done. Well done. Can I do the same thing here? Definitely not. Definitely not. Okay. Yeah, I can already see it. Okay, okay. I wish I'd seen that earlier. It would save me 10 minutes or so, and it's very, very beautiful. Um, okay. I'm going to draw in, because this is a modular line, it's taking one of each group. This also has to be a modular line from one of each group, and I'll just draw that in. These are the same modularity, and green has to go on here. So this is also green. This is green. Green has to go on here somewhere. So it's these two. Green is one of these and one of these. Green, no, one of these is green, but I don't know which, right? Because this is not green. So one of these has to be green, which means that's not green. One of these is green. These aren't green. So it's either these are green or these are green. If these are green, where's my second green in this box? It's got to be here, right? But I think that will break this line. If where is green on this modular line? It's certainly not here because both greens are taken. This I think works. If it's these, what happens? So I'm just going to fill that in to show you what happens. If that's green, I need to put a second green in this box. I can't go here or here, so it's got to go here. But that just immediately conflicts with this. But what I actually saw in my head is not that, but that I also need to put a green on this line, which couldn't go here by this. And so it'd have to go here, but then I'd get 3 in this column. So green's not there. These are green. One of these is still green. That's not green. That's not green. This is green. I need another green on here, and a green on here, and a green on here. I don't think I can do better than that. So let's add another one. Where do I want to add it? I think I just got very lucky with that. This seems pretty good, because if these are the other one, that's orange. No orange here, that's orange. I need one of these to be orange, so that's not orange, which means that's orange, or that's not orange more obviously. We'll call these then purple. That's purple, so this is orange. This is what's left, purple. I need a green and a purple here, of course. I need an orange and a purple here, of course. I get, oh no, that's fine. These are purple. Purple's not on here, so purple is here. These are all purple and orange. This is orange. One of each here. This isn't purple because I have 2 purples already. So that's the orange. Oops. That's the purple. One of each here. So that's orange. This is whatever this is, which is not green, of course. I don't know. Is this enough to do something with the 10? I know orange is now 1 or 4 because, so one of each kind will have, if I add them up, will have a modularity of 0. It's like 1 plus 2 plus 3 is 6. So that it's kind of in the 3, 6 group where, and 10 has a modularity of 1 mod 3. So if I add the orange, that has to be the same as the modularity of 10. So oranges are 1 and 4. These can't both be 4, but 1 and 4 would work fine. Those would have to be 2 and 3. 1 and 1 also works. This could be 3 and 5 or 2 and 6. So the only thing that's true is these can't, but this sees both of them. So these have to be the same, and they can't be 4, so they're 1. That's a 4, that's a 4, 4. I get a 1 on this. I get a 4, I get a 4. I don't know. Here and here. Okay, so these add to 8. What about this? This is not 1. 2, 3, this could still be 6. Okay. 1 is on here. Yeah. Okay. How about this 13? Same thing. This can't be orange because then I'd have 1 of each. That would have a modularity of 0, which doesn't match 13. So this is not orange, which means it's purple. So this is orange. So this is purple. I still don't know, but I know that's not. So that's the 4, which is orange. And this circle is green. What is color? Green. I need a green here with an orange. Here I need a purple and an orange. Here I need a purple and a green. I don't think I can do more with that. But now I get 2 purples and a green. Green and purple will also, because, oh no, I had it wrong. One of these, hold on. The 4 is here. If purple is the 3, 6, then this has modularity 2. That works. If green is 3, 6, this is modularity 1, which doesn't work. So, no, I got that wrong. Hold on. 13 has modularity 1. So if these are 3, 6, this is modularity 1, which does not work. If this is, because that's already taken. Modularity 3 also has modularity 0. So let me just explain that. I don't think I did a good job. Let me back up one step. If I sum these together, they will add up to 13. But one of the properties of modular arithmetic is that if I add the modular remainder of 2 or 3, however many numbers you like, its sum will have the same modular remainder as the sum. Sorry, the modular remainder of the sum will be the same as the sum of the modular remainders. So, I can treat one of these is the 3, 6 group, which I'll call 0. Because 3 mod 3 has a remainder of 0. And one of these is the 2, 5 group, which has a remainder of 2. So there's 2 ways this could go around. Either this is, the purples are 0, and that's 2. In which case, this sum would have a modular remainder of 2, 0 plus 0 plus 2, which does not match the 13. So that doesn't work. Other way around, which will work, is that the purples have a modular remainder of 2, the green has a modular remainder of 0, and that'll be 2 plus 2 plus 0 is 4. 4 is the same as 1 mod 3, which is the same as 13 mod 3. So this way works. So greens are 3 or 6, purples are 2 or 5. And to make this work, 5, 5, 3 works. These can't be different because they see this. It's very similar logic. 2, so if these are 2, 2, I can't make this high enough for the 13 to work. So these are 5, which makes this 2 and this 3. And I think I might have to use the 11, I guess, for one last little trick. This is 1 and 6. I don't know that yet, actually. 2, 5, 2, 6, 3. 2, 5, 6, 3. These are from 5, 6. So that's 3. So that's 6. That's 5. 1. Oh, did I do that wrong? Hold on. Going too quickly. Let's back up a step. So I think that's okay. 2, 5. This is 5, 6. So that's 3. 5, 6. Oh, I just put the wrong number there. 6, 1, 2, 5. I do that all the time. This is 1, 2. It goes this way. I hope that's right. Now we get to go back to the treasure chest. And now these are modular lines. So these are the same. These are the same. Oh, but I don't know which they are. Oh, I don't have 5 or 6 anymore because it's a 2 by 2. It's a 4-digit Sudoku. So this has to be 1, 4. And these are the same. These are the same and also 1, 4. These are all 2, 3, which means this is 1, 4. I'm just gonna separate green, like orange and green maybe. And if I have to worry about those, I will. These are green. These are orange. That's green. That's orange. How does this work? This sums to 5 for sure. So this sums to 3. This has to be 2, 1. That hopefully will solve the puzzle. 1, 4, 1, 4. At least does those. 3, 2, 3, 3, 2, 3, 2. Solve the puzzle. Amazing. Yeah, this is great. Uh, yeah, I'm a little bit in awe of how many times you could make that puzzle work, especially that first puzzle with all those different lines. And then to have the Renban and the modular line overlap. Yeah, it's just perfect. It's great. So thanks, Nurator, for setting this puzzle and sending it in to me. And thanks everyone for watching, and I'll see you next time.